This is video 2 for section 5.1. First turn to page 126 of your journal and look at the rational exponents. When you have an exponent like a fraction m to the n, you can write it as a power and a root. And what you want to remember is the fraction gives you the power number over the root number. For instance, if you have 4 to the 3 halves, that's like saying 4 to a power of 3 and a square root. And then you can simplify this. I would do what would make this number smaller first. So do the square root of 4, which is 2, and then you can cube 2, which is 8. Now if you have a negative rational exponent, that just means you're going to flip where it's at. So if the number is in the numerator of a fraction and it's negative, you're going to bring it to the denominator or make it 1 over. So if I have 1 over 4 to the 3 halves, I can now make this 1 over power over root. So power of 3. Go ahead and do the square root like we did, and then the power, which would make this 1/8. So the negative moves the whole entire problem into the denominator. Now let's move to our notes packet. You can read what we have here at the top. You can see that a power rule says you can do a half times the 2 and get a power of 1, which is just a. So you have 1/3 to the 3rd power is going to give you a power of 1, or 1/4 to the 4th power. Multiply those exponents and you always get 1. Because a to the half is a number whose square is a, you can write a to the half as the square root of a. It's kind of like first power square root. So the cube root of a can also be written as a to the 1/3 power. 4th root of a can be written as a to the 1/4, and so on. Nth root of a is a to the 1 over n. So let's try example 2, evaluating expressions with rational exponents. The first thing you want to do is rewrite using radicals. So we have 16 to a power of 3 and then a square root. Because the 3 and the 2. The 3 is the power, the 2 is the root. It's always power over root. Memorize that. So now let's evaluate this. We can figure out the square root of 16 in our head. That's 4. So now let's do 4 cubed, which will be 64 as our final answer. Now let's try B. The first thing I like to do is get rid of the fact that this is negative by placing it in the denominator, and now the exponent will turn positive. Now let's rewrite using radicals. We will have 32 to a power of 3 and then 5th root. Make the number smaller by taking the 5th root of 32 first. So what number 5 times will equal 32? And that'll be 2. And then you can cube the 2 and get 1 over 8 as your final answer. Now let's move to example 3, which is approximating expressions using a calculator. Okay, so these won't be like perfect squares or perfect cubes, so we're going to have to round our answer. So these won't be exact answers. We're going to be approximating. So the symbol for approximating will have like these 2 squiggle marks. And then we have to enter this in our calculator. So let's take out our calculator, and we want to type 9 to the 1/5 power. So 9 raised to, you're going to use the little caret button here. And we're raising to the 1/5 power, which is a fraction. If you hit Control Divide, you'll pull up a fraction, and you put 1 over the 5, and then hit Enter, and you get your answer. And they want 2 decimal places, so we're just going to type 1.55 into our notes. So you can see we have 1.55. Let's try letter B, 12 to the 3/8. So let's go to our calculator. We're doing 12 raised to a fraction of 3 over 8. Oops. And then hit Enter. And write it to 2 decimal places. So 2.54 will go into our notes. And the last example, you can type exactly how you see it, but it might be easier to rewrite this as a rational exponent. Get rid of the radical. So 7 has a power of 3 and a root of 4. So we rewrote 7 to the power of 3/4, and let's enter that into our calculator. 7 raised to the fraction 3/4, and the answer will be 4.30. You can write that into your notes, 4.30. Now look at Monitoring Progress, problems 5 through 12. For problems 5 through 8, you want to rewrite using radicals and then try and evaluate without a calculator. But in problems 9 through 12, you're going to actually rewrite any into exponent form and then put it into a calculator and actually use a calculator.